Welcome you all again. So in the previous session we were discussing about the network theorem, and in that particular session we have discussed Thevenin theorem and superposition theorem. So in superposition theorem state that if there is a two or more than two type of sources are there, then response in any particular branch is equal to the algebraic sum of the response when one source considered at a time and remaining sources are replaced by their internal resistance. And in case of Thevenin theorem states that any two terminal bilateral active network can be replaced by simple Thevenin voltage in series with Thevenin resistance. And Thevenin voltage is open circuit voltage across two terminal, and Thevenin resistance is equivalent resistance looking from two terminal into a network. So now today I am going to discuss about next two theorem, that is a Norton theorem and maximum power transfer theorem. So Norton theorem states that any two terminal bilateral active network can be replaced by simple Norton current source in parallel with Norton equivalent resistance. And what is this Norton current source? Norton current is nothing but it is a short circuit current through the terminal, and Norton resistance is similar to the Thevenin resistance. That means if you want to calculate the Norton resistance, so Norton resistance is the equivalent resistance looking from two terminal into a network while all independent energy sources are replaced by their internal resistance. Suppose there is a ideal voltage source, that means you have to replace this ideal voltage source by the short circuit. If there is a ideal current source, then you have to replace this ideal current source by open circuit. Now here you can see this figure A shows a simple block representation of a network with several active and passive element with the load resistance RL connected across the terminal A and B, and this is a equivalent circuit. Here you can see this is Norton current. This Norton current is what? Norton current is nothing but it is a short circuit current flowing through the two terminal, and this Norton resistance is what? Norton resistance is nothing but it is a equivalent resistance looking from two terminal into a network while all independent energy sources are replaced by their internal resistance, and this one is a load resistance. Suppose you have to find the value of the current load resistance IL. So how you can calculate current IL? Because this I and current will be divided in these two paths, that is through the current flowing through this resistance Rn and current flowing through this IL. So IL is equal to what? IL is equal to IN multiplied by the resistance of opposite branch, that is IL into Rn, upon summation of resistance of these two branches. One branch is this one, another branch is this one. So IL is equal to what? IN upon Rn plus RL. Now there are different steps to find out the value of the short circuit current, or you can say the Norton current, and there is another step that how you can calculate the Norton resistance. So first step is what? The terminals of the branch or element through which the current is to be found out are marked as say A and B after removing the concerned branch or element. So this is a first step. In the second step, what you have to do? After the short circuiting these two terminal A and B by zero resistance wire, find the ISC, because you have to replace the short circuit current. Short circuit current means what? Zero resistance. So find ISC through these two terminal using the conventional network, either with the help of the mesh analysis or with the help of the node analysis method. You can also apply the Kirchhoff's voltage law, you can also apply the Kirchhoff's current law, and for solving this type of network you can also apply the superposition theorem also. And in the third step, so next step is what? You have to find the Norton resistance. So to calculate the Norton resistance, the method is the same as you calculate the Thevenin resistance. So Norton resistance is what? Is the equivalent resistance looking from two terminal into a network while all independent energy sources are replaced by their internal resistance. So there may be the two cases when you have to find the Norton resistance. First case is what? When there are dependent source. So if there is a dependent source are there, then you have to find the Norton resistance by this formula, that means you have to calculate the open circuit voltage across the two terminal A and B. At the same time, you have to also calculate the short circuit current ISC, that is a Norton current. So just BOC divided by ISC will give you the value of the Norton resistance if there are dependent sources are working in any circuit or network. Second case is what? If there is only dependent sources. So if there is only dependent sources, like it may be the ideal voltage source or it may be the ideal current source. So Norton resistance is what? Is equivalent resistance looking into the concerned terminal with all voltage and current source replaced by their internal resistances. So as I am saying again and again, if there is an ideal voltage source, that means you have to replace by the short circuit, because internal resistance of ideal voltage source is 0. If there is an ideal current source, then you have to replace by open circuit. Why open circuit means what? That means internal resistance of ideal current source is infinite. So infinite means what? Resistance is infinite, or this can be replaced by open circuit. So replace the network with the IN. Here you can see, because you have calculated the Norton current, or you can say it is a short circuit current in parallel with the Norton equivalent resistance. So just you put this Norton resistance in parallel with the Norton current, and you connect load resistance as shown in the figure. So now you have to calculate the current IL flowing through the load resistance, because this current is IN, this current is dividing in these two branches. One branch is this one, another branch is this one. So if you have to calculate current this IL, so how do you calculate the current in this branch, that is load resistance? By just applied the current division rule. And current division rule states that in which branch you want to calculate the current, just multiplied by the resistance of opposite branch. That means total current multiplied by the resistance of opposite branch. So opposite branch of load resistance is what? This Norton resistance, just you multiplied IN multiplied by RN. Then you divide by summation of the resistance of two branches. And what are those two branches? One branch is this one, which having a resistance Norton resistance RN, and another branch having a resistance load resistance RL. So IL is equal to what? IN multiplied by RN upon RN plus RL. So what Norton theorem states that? Norton theorem states that any two terminal bilateral active network can be replaced by simple Norton current source in parallel with Norton equivalent resistance. And what is a Norton current? Norton current is nothing but it is a short circuit current flowing through terminals, and Norton resistance is what? It is a equivalent resistance looking from two terminal into a network, while all independent energy sources are replaced by their internal resistance. And internal resistance of ideal voltage source is 0, and internal resistance of ideal current source is infinite. Now Norton's theorem can also be explained with help of one example. So here you can see there is a circuit which have two meshes. One mesh is this one, another mesh is this one, and there is a two voltage source which have 10 voltage source. This is ideal voltage source because there is no internal resistance of this voltage source, and another voltage source is what? 20 voltage source. This is also ideal voltage source because it doesn't have any internal resistance. And these three resistances having value 10 ohm, 20 ohm and 40 ohm. Now by applying the Norton theorem, you have to find out the current through this 40 ohm resistance, or you have to find the voltage across this 40 ohm resistance. So what is the first step? First step is what? In which branch you have to find out the current or voltage, just replace this branch from this figure. So just remove this this branch A and B from this network. So just you replace this branch A and B. So what? How it will be? Look, it will be the open circuit because you have to find the short circuit. So what you will do? By replacing this 40 ohm resistance, you connect this terminal A and B with help of some wire which have zero resistance. So it is sorted out. So this is a short circuited between terminal A and B. Now this, whatever the current flowing through this wire AB will be called as short circuit current, or you can say Norton current. Now how you can calculate this Norton current flowing through this terminal in this situation? Here you can see there is a 2 voltage sources. So this can be calculated either by the help by applying the mesh analysis, or you can also calculate the current flowing through this branch by applying the nodal analysis, or you can also calculate the current flowing through this wire A and B with help of the superposition theorem. So superposition theorem is very simple in comparison to the two method, that is mesh analysis and nodal analysis. So in superposition theorem, what do? You have to consider one source at a time, and remaining sources are replaced by their internal resistance. So first of all, you consider one source, that is 10 voltage source, and you replace this 20 volt source by their internal resistance. So how this circuit will be converted? Here you can calculate. So it will be the short circuited. So whatever the current will flow through this 10 voltage, this current will be divided in this branch and this branch. So with terminal A and B are sorted together, two resistors are connected in parallel across their two respective voltage sources, and the current flowing through each resistor as well as the total short circuit current can be calculated as by applying the superposition theorem. So I1 is equal to what? 10 divided by 10. Why? Because this is short circuit current, and current always flows through the least resistance path. So whatever the current will flow this through 10 voltage source, total current will flow through only this circuit. Because if you want to calculate, this is a short circuited, so if you want to calculate the equivalent resistance of this particular mesh, so this resistance 0 multiplied by any resistance is equal to what? 0 resistance. So total current will flow through only this branch. So this current, let I1 is equal to what? 10 divided by 10, that is a 1 ampere current. So you have applied superposition theorem when you are considering this 10 voltage source. Now you consider this 20 voltage source, then what you will do? You will replace this 10 voltage source by the short circuit. So now how current will flow? Again this current will flow through only this branch. Why? Because this is a short circuited and this is also short circuited. So equivalent resistance of this particular two branches is equal to 0. So net current will flow only through this path. So that current, you can say that current I2. So I2 is equal to what? 20 divided by 20. So again it is a 1 ampere. So when you are considering this 10 voltage source, that current I1 is flowing in this direction from A to B, that is a 1 ampere. When you are considering this 20 voltage source, then current is again 1 ampere, because 20 divided by 20 is a 1 ampere, and at that moment is also current is flowing from A to B. So what superposition theorem states that it will be equal to the algebraic sum. So current flowing through these two individual voltage source are in the same direction. So ISC can be written as ISC is equal to what? I1 plus I2, and I1 is equal to what? I1 is equal to 1 ampere when 10 voltage source was considered and 20 voltage source was short circuited, and I2 is equal to what? I2 is equal to again 1 ampere when 20 voltage source is considered and 10 voltage source is replaced by short circuited. So ISC current or Norton current is equal to what? I1 plus I2, that is 1 plus 1, that is equal to 2 ampere. Now for the Norton theorem, you have achieved Norton current, that is a 2 ampere. This Norton current is also can be termed as short circuit current. Now next step is what? Next step is to find the Norton resistance. So how do we calculate the Norton resistance? Norton resistance is the equivalent resistance looking from two terminal into a network. So you are looking from this terminal A and B. It can be considered as you are looking from this terminal, while all independent energy sources are replaced by their internal resistance. So there was two independent energy sources. One was here, that is a E1, that is a voltage source, so it is replaced by short circuit, and another was again that was a energy source, that is a voltage source, it is also replaced by short circuited. So these two voltage sources are replaced by internal resistance. Now you have to find out the equivalent resistance from looking from terminal A and B. So here you can see, because just you flow some imaginary current, just you assume that. So suppose this current is flowing from this point, so this current will be divided in this branch and in this branch. That means this branch this branch and this branch is in parallel. That means 10 ohm is in parallel with 20 ohm. So what will be the equivalent resistance? 1 upon Rn is equal to 1 upon 10 plus 1 upon 20, or you can say Rn is equal to what? 20 into 10 upon 20 plus 10. That is, after the solving this equation, you will be able to calculate the equivalent resistance, that is 6.67 ohm. So you have achieved Norton current or short circuit current, and you have also calculated the Norton resistance and equivalent resistance. So what Norton said that whatever the resistance you are calculating, just a Norton resistance, just place in parallel with the Norton current. So Norton current is 2 ampere and Norton resistance is 6.67 ohm, and just you put this load resistance 40 ohm across terminal AB. Now you have to calculate the current, this IL flowing from terminal A and B. So again this Norton current or short circuit current will divide in these two branch. One is through the RS, that is 6.67 ohm, and through the load resistance 40 ohm. Because you are calculating the current from terminal A and B, this current is termed as IL, that is a load current. So how do you calculate the load current IL? Just you apply the current division rule, and current division rule states that current flowing through this terminal AB is equal to the total current, and total current is what? That is a Norton current multiplied by the resistance of opposite branch. So opposite branch of AB is what? This Norton resistance multiplied by this Rn upon summation of the two resistances, Rn plus RL. So value of RL is what? 40 ohm, and resistance of this short circuit resistance, or you can say Norton resistance, is what? 6.67. So 2 into 6.67 divided by 6.67 plus 40. So this comes 0.286 ampere. So this is how you have calculated the load current with help of the Norton theorem. Now suppose you have to calculate the load voltage BAB, or you can say BL, that means voltage drop across load resistance RL. So how do you calculate this voltage VL? VL is equal to what? Current flowing this branch, that is IL, multiplied by the resistance of this branch. So VL is equal to what? IL multiplied by RL. So this is how you can calculate the load resistance, load current and load voltage. Similarly, suppose you have to find out the heat losses through this resistance. So heat loss is equal to what? I square R, that is I square what? I means what? Load current IL square multiplied by RL. So this is how you can calculate the current, load resistance and load voltage through the load resistance with help of the Norton theorem. Now conversion of the Thevenin's equivalent into the Norton's equivalent. That means you can convert Thevenin equivalent into the Norton equivalent. Here it is very interesting to note that Thevenin equivalent is like a ideal voltage source, and Norton equivalent is like a basically current source. So a Thevenin equivalent can be converted into its Norton equivalent and vice versa. According to the statement, Norton current source equal to the ISC or IN that flows across the terminals A and B when they are short circuited. Right. So now you have to convert this Thevenin equivalent into Norton equivalent. So that means you have to calculate the Norton current. How can you calculate this Norton current IN? IN is equal to what? This VTH divided by this RTH, or you can say RN, because Thevenin resistance and Norton resistance are the same. The methodology to find out the equivalent resistance for the Thevenin theorem and for the Norton theorem is the same. So you can say RN and RTH are the same. So IN is equal to what? IN is equal to VTH divided by RN. And whatever this resistance are here, which is in series with the VTH, just put in parallel with Norton resistance. So you can convert Norton into Thevenin equivalent into Norton equivalent. Next is conversion of Norton equivalent into Thevenin equivalent. Likewise, a Norton circuit can be converted into its Thevenin equivalent. The Thevenin's equivalent source BOC or BTH, because BTH is what? BTH is nothing but it is an open circuit voltage across two terminal, is given by as BOC or BTH is equal to what? This ISC multiplied by this RTH or RN, then you will be able to find out the voltage of Thevenin voltage. So here you can see it is like a current source, it is like a voltage source. So just multiplied by this Norton current and multiplied by this Norton resistance, it will give you the value of the BTH, and whatever the Norton resistance are in parallel with the Norton current source, just you connect in series with the Thevenin voltage. This is how you can convert Norton equivalent into Thevenin equivalent, and also you can convert Thevenin equivalent into a Norton equivalent. Now we have to understand next theorem, that is a maximum power transfer theorem. So first of all we have to understand what is the need of the maximum power transfer theorem. In many practical situations, a circuit is designed to provide power to a load. While for electric utilities, minimizing power losses in the process of transmission and distribution is critical for efficiency and economic reason. There are other applications in areas such as communication, where it is desirable to maximize the power delivered to the load. Electrical applications with electrical loads such as loudspeaker, antennas, motors, etc., it would be required to find out the condition under which maximum power would be transferred from the circuit to the load. So in the communication circuit, there is a importance of the maximum power transfer theorem. But if you are talking about the power system, this maximum power transfer theorem is of no use. So for the communication circuit, like suppose you are using the loudspeaker, that means you have to transmit the maximum power. So how this maximum power can be transferred from source to load, this can be understood by with help of the maximum power transfer theorem. So in any linear bilateral two-terminal network consisting of resistance load, here you can see this is resistance load, being connected to the DC source, maximum power will be transferred from source to the load when this load resistance is equal to the Thevenin resistance of the network. That means maximum power will be transferred from source to the load when this RL is equal to the RTH. That means whenever you have to find out the maximum power, so what you have to calculate in any network, you have to find out the value of the Thevenin voltage, at the same time you have to find the Thevenin resistance. So as you are very familiar with the Thevenin theorem, so you can easily apply the maximum power transfer theorem in any network if you want to transfer the maximum power from source to load. So in this circuit, how you can calculate this load current I? This current I is equal to what? This voltage BTH divided by these two resistance RTH plus RL. So I is equal to what? BTH upon RTH plus RL. So power delivered by the circuit to the load can be calculated as P is equal to what? I square R. And what is the value of I? I is equal to what? BTH upon RTH plus RL. So I is equal to what? BTH square upon RTH plus RL whole square multiplied by this R. R is what? This is load resistance, because this power is being transferred to the load resistance. Now you have to find the condition at which maximum power is transferred. The condition for the maximum power transfer can be obtained by differentiating the above expression for power delivered with respect to the load resistance. Since we want to find out the value of load resistance for the maximum power and equating it to 0. So just you differentiate this P with respect to the RL, that means dP upon DRL. So dP upon DRL is equal to 0, you have to put as a 0. So when you will differentiate, after the differentiating this term, you will get this term BTH square upon RTH plus RL square minus 2 BTH square upon RTH plus RL whole cube into RL, because this is equal to 0. So this term left hand side is equal to the right hand side. So after the solving the equation, you will find out this equation, RTH plus RL minus 2RL is equal to 0. So this you can write RTH plus RL is equal to 2RL, or you can say RTH is equal to 2RL minus RL, or you can say RL is equal to RTH. So this is the condition when maximum power will be transferred from source to load. And what is this condition? When load condition is when load resistance is equal to the RTH, then maximum power will be transferred. Now you have to find this maximum power. What is the value of this maximum power transfer? So equation is what? Equation is this one. For equation for the power is equal to what? P is equal to BTH square upon RTH plus RL square into RL. So just replace value of RL is equal to RTH. So you can put RL is equal to RTH and it will be what? P max is equal to what? BTH square upon RL plus RL into RL. So what will be value of this? This is 2RL. 2RL square means 4RL square. So BTH square upon 4RL square into RL. So R square will be cancelled by the RL. So P max is equal to what? BTH square upon 4RL. So this is a formula to calculate the maximum power transferred from source to load. So if any numerical comes and it is asked, you find out the maximum power transfer from source to load. So formula for that is equal to what? P max is equal to BTH square upon 4RL. That means to calculate this maximum power, what you have to find out the parameter, that is BTH, that is Thevenin voltage, and Thevenin voltage can be easily calculated like BTH is equal to what? Open circuit voltage across two terminal, and RTH is equal to what? RTH is equal to the Thevenin resistance, or you can say equivalent resistance looking from two terminal into a network, while all independent energy sources are replaced by their internal resistances. Now you have calculated the maximum power, or you can say this is the output power. Now because you have to find out the efficiency, so efficiency can be calculated as efficiency is equal to what? Output power upon input power. And how you can calculate the input power? Input power is what? If you add losses to the output power, then you can say this is a input power. So just now you find out the power losses. Power losses is equal to what? IL square. That means this losses will be happen in the network, and total resistance of the network is what? RTH. That means IL square into RTH, and value of IL is equal to what? BTH upon 2RL whole square. That means it is BTH square upon 4RL. This is the losses. So power losses can be written as BTH square upon RL plus RL square into RTH, that is BTH square upon 4RL. Now you add this loss to the output, then you can find out the input. So efficiency is equal to what? Output upon input, and output is what? BTH square upon 4RL, and input is what? This plus this, means BTH square upon 4RL plus BTH square upon 4RL. So after the solving, you are able to calculate efficiency is equal to 0.5, or you can say efficiency is equal to 50%. So for maximum power transfer, the load resistance should be equal to the Thevenin equivalent resistance or Norton equivalent resistance, because the methodology to find out the Thevenin resistance and Norton equivalent resistance is the same. And under the condition of the maximum power transfer theorem, efficiency will always be 50%. Generally, this question is asked in the examination or in the Viva, what is the efficiency of the maximum power transfer theorem. So this efficiency will always become 50%. It will not be 40% or 42%. So maximum efficiency of the maximum power transfer theorem is always 50%. Now with help of the one example, we can understood the maximum power transfer. So here you can see there is a two source, that is a 12 voltage source, and another is a one current source 2 ampere. It is connected in this manner. There is a number of resistance 6 ohm, 12 ohm, 3 ohm, 2 ohm, and this load resistance RL. Now you have to find the maximum power transfer from this circuit. This is a whole circuit to the load resistance RL. So what are the steps? Step is to find out, first step is to find out the Thevenin voltage. So, or you have to find the Thevenin resistance. So Thevenin resistance is what? Thevenin resistance is the equivalent resistance looking from two terminal into a network, while all independent energy sources are replaced by internal resistance. So this is a voltage source just replaced by the short circuit, and this current source is replaced by open circuit. So circuit will be converted in this form. So here you can see, because you are looking from this side, so this 12 ohm is in parallel with 6 ohm. So 6 is parallel with 12, and this resistance are connected in series with this 3 ohm and 2 ohm. So this 2 ohm plus 3 ohm is in parallel with this 6 ohm and 12 ohm. So after the solving, you will find out the equivalent resistance, that is 5 plus 4, that is 9 ohm. So you have calculated the Thevenin resistance RTH. Now because you have to calculate the maximum power, and maximum power is equal to what? BTH square upon 4 RTH. That means you have to find out the value of BTH. So to get the BTH, we consider the circuit as in shown in the figure B. Applying the mesh analysis, just you apply the mesh analysis, so it will be minus 12 plus 6 plus 12, that is 18 I1 minus 12 I2, because the current, net current flowing through this 12 ohm is equal to what? I1 minus I2. So minus 12 plus 18 I1 minus 12 I2 equal to 0, because this is a open circuit. That means there is no current will flow through this branch. So whatever the current is flowing through, only this mesh. So minus 12 plus 18 I1 minus 12 I2 equal to 0. Here you can notice this I2, that is loop current, I2 is equal to what? 2 ampere, because this current is flowing, and direction of this I2 and 2 ampere is opposite. So you can say this loop current I2 is equal to what? Minus 2 ampere. Just put the value of this I2 equal to 2 ampere in this equation, then you can easily find out the current I1. So after the solving, you will get I1 is equal to minus 2 by 3. And applying the KVL around the outer loop, you can calculate the BTH across the terminal AB. So what will be the voltage across this one? That means whatever the voltage drop across this one plus this one. So BTH can be calculated as minus 12 plus 6 I1 plus 3 I2 plus 2 into 0. 2 into 0 is why it is 0? Because there is no current in this branch. That's why it is multiplied by 0. Plus BTH equal to 0. So BTH is equal to what? 22 voltage. Now you have achieved, or you have calculated the Thevenin voltage. You have also calculated the Thevenin resistance. So you can easily calculate the maximum power. So what is the maximum power? P max is equal to what? BTH square upon 4 RL. So BTH is equal to what? 22. It is square, so 22 into 22 into 4 into RL. RL is equal to what? RTH. So after the solving, this value comes, that is 13.44 watt. So you have calculated the maximum power transferred from source to load. So in this particular session, we have discussed the Norton theorem and the maximum power transfer theorem, and these all the theorems are very useful to analyze the circuit. It is very helpful. It works like a tool to calculate the value of the current, to calculate the value of the voltage in any circuit. And maximum power transfer theorem is very useful in the electronic circuit where maximum power has to be calculated. This is all about the second session. Thank you very much.